Hello, my name is Gregory Ivo. I'm the current in-house intern at Eclipse IoT, and I'm excited to show you my current project, the Robotic Courier Network. Before we start, I want you to think about this quote for a second. Anything that can be automated will be automated, and anything that's left will become 100 times more valuable. Tariq Karishi. To be most effective, all workers must spend their time focusing on what they do best. Although seemingly simple, this tends to not always be the case. In a dynamic factory or warehouse, it has become common that one individual holds the responsibility of a variety of different roles, proving it to be difficult for them to focus on the one task they do best. Not only do these many different roles affect productivity, they can actually put your staff at risk. Tasks, as simple as moving a box from point A to point B, also known as manual handling, can prove to be dangerous, and is said to be one of the biggest causes of workplace injury. The solution to this unwavering issue is not new to the world, but if implemented correctly, can be revolutionary. This solution is automation. With growing research in computers, AI, edge computing, and robotics, the idea of automating everything has never appeared so possible. This demonstration that we're doing today specifically focuses on the automation of manual handling. In this example, we have a warehouse with 2 stations, and these stations require cooperation. Often, a worker at station A requires something that is at station B, and vice versa. Employees spend cumulatively hours walking between these stations over a course of a week. To solve this, we use a combination of edge computing and robotics. Firstly, I'd like to introduce the Turtlebot 3 Burger, which is a robot that runs ROS2. ROS2 is a set of libraries and tools for building a robot-based application. This robot, combined with an edge server, is capable of performing autonomous navigation, and this bot will be used to make deliveries between stations. Secondly, each station has an embedded edge node for human interface. These nodes are Raspberry Pis with a little push button, and when a worker pushes the button on the Pi, our robot will almost magically travel to the station with a package in hand. In order to make this possible, all edge nodes must have some way to negotiate. In this project, we use Xeno. Xeno is a protocol in which nodes can be consumers, publishers, or both at the same time. That runs on all of our nodes for communication. Altogether, we get something I call an RCN, or the Robotic Courier Network. This demo has some assembly required, so before I can actually show you it all working, I need to put together the Turtlebot and make some 3D prints. Now to the fun part. Let's see it all in action. On our computer, we need to run the bring-up script for our Turtlebot, run servers on our 3 different edge nodes, and lastly start up Nav2 and RViz. These 2 ROS applications handle all the autonomous navigation on the Turtlebot. I now need to set the approximate 2D position of our Turtlebot with respect to my space, and finally we're ready to navigate. Welcome to my bedroom warehouse. Here we have our lovely Turtlebot 3. Station 1, Station 2. When this button is pressed, the Pi will use Xeno to negotiate with the other Raspberry Pi. Then, the other Raspberry Pi will send the resulting positions of both stations and navigation order to the master server. Using ROS, RViz, and Nav2, this server will then send messages to the Turtlebot telling it exactly how and when to move. And 3, 2, 1. And right here is the exact moment everything goes wrong. This solution works. The robot is actually able to move between these 2 points. But sadly, the precision is nowhere near what we need to have a solution like this implemented in industry. So half the time, this is what happens. Okay, let's go back to reality for a second. In order to improve the success rate for this demo, we need to give the robot more information about its target position. As we can see from the footage, the robot can easily navigate to the front of the box, but struggles with the rotation and lining up in order to have a direct approach to the arm. If we look at RViz, we can see the world from the robot's point of view. And our goals look like a tiny little insignificant landmark and can probably easily blend into the walls. To solve this, let's look at a pre-existing solution for robot vacuums. They're able to navigate to their docking stations quite accurately. For example, this Nito robot vacuum is able to recognize its position based off this big rectangle on the base station. But the question is, what is this rectangle? The only way to answer that is by taking it apart and praying I don't destroy my precious home electronics. After a teardown, we learned that other than the charger, the base station is completely passive. This rectangle appears to be some sort of infrared filter, and the robot's onboard LiDAR sensor is doing all the work to figure out its positioning with respect to the base. This means that with these infrared reflectors and a little more softer tuning, it would be entirely possible to increase the Turtlebot's success rate during the process of navigating inside the box in this demo. I hope you found this video informative and entertaining. This is my last video as an Eclipse IoT intern, and I want to thank the team at Eclipse for the amazing 4 months I've had with them. Thank you for watching. Want to see more Eclipse IoT projects? Check us out at github.com/EclipseIoT or at iot.eclipse.org. Thank you for watching.